So I was saying that the two answers you are likely to get, x will be equal to x1. We get two answers. X1 is equal to a, and then x2 is also equal to a. How do we get them? If I use this one to explain to you, it looks so complex. So I'll use an example. But at the end of the day, all we are going to do is to find two numbers. The first number will be A, the second will be B. And so A and B will first of all add up here. And then secondly, they will multiply here. That's what I want you to watch out for. Any expression that will give you two brackets like this. Each of the brackets is called a factor. So if you have two factors that is starting with a certain variable square like x squared, this x squared means you are going to get two values of x. The first one is here and the second one is here. And then the other numbers you see after the x, which is the a and the b. What I'm trying to say is that when you come on the right-hand side, these two answers you are going to get, A and B, first of all, they will add up here. And then secondly, they will multiply and be written here. Let's pick an example to illustrate what I'm trying to say. If you have a question like this, and they say factorize, factorize means that this number looks too straight. Try and work them out in such a way that you get two brackets. You get a first bracket, you get a second bracket. So any arrangement like this is called factorization. It means that it's like you are boxing the numbers, or you are putting the numbers in a box. Same like probably you are buying a food at a restaurant, and then they are bagging the food for you. You see that it is food you have bought. So probably if it's banku and tilapia, the banku is put in a different pack. And then the tilapia is also put in a different pack. When that is done for you, you see your food has been factorized. Your food has been put into factors, or your food has been packaged differently. Even though when it's time for you to eat, you unpack them. When it's time for you to eat, you unpack them. So these two things that have been packed, when you are ready to eat, you open up. So you have the banku in the bowl, and then you also have the tilapia in a bowl or in a pack. Then you come back to what we are seeing here. So this expression actually is a raw expression we want to package, or we want to put in a pack, which we call factorization. The question is, how is it done? How is the packaging done? Let's learn it. Let's walk through and learn how to package numbers like that when they are given to you. And it follows one key principle. And this is the principle that follows. First of all, any number that starts with a square, a variable square, is called a quadratic polynomial. A quadratic polynomial. So polynomials are algebraic expressions. And last week, we learned how to write some algebraic expressions. Now, quadratic terms has three terms: 1, 2, 3. But the packaging we want to do, which are the two brackets, you are going to have four members. So you have x here, You have a certain number here. You have X here. You have another number here. When you count the numbers or the members in the bracket, you get 4. 1, 2, 3, 4. Meanwhile, before the packaging, it is 3. 1, 2, 3. So the question is, how can we do something to this equation to be able to get 4 members, and then we package them 2 by 2, like you are seeing here? This is the principle. I want to write some steps down. We follow the steps, and then we work with it. This type of expressions, x squared, 4x, and 3, like this, is actually x, which is going down. So it was a squared here, and then 1 was subtracted from these 2, and then became 1, plus 3. And then this same x is coming. So as you move to the right, you are taking 1. So initially it was x squared, 1 was taken, and then became x1. And then moving to the next right, 1 was taken from this, and it became x0. So in writing it in proper form, x squared, you can't do anything about it. So you write x squared plus any number of variable raised to the power 1 is the same variable. So this is also written as 4x. And then in mathematics, any variable or number raised to the power 0 is 1. So it becomes 3 times 1, and you have 3. So this expression you are actually seeing here as our first expression. This wasn't how originally it was. Originally, this x here had a power 1 because 1 has been subtracted from these 2 as you move to the right. And then when we came to the 3, the x was there.
Go to the hall. I'm learning. So I don't want it. So, but if you be here and you will not be making noise, that's fine.
But when you move to the right, you still subtract 1 from here and become 0. And that's what I did here. Any number raised to the power 0 is 1. So it will let this one disappear. Any number raised to the power 1 is the same number. So it will let this disappear. So actually, for every quadratic polynomial, the powers of the variable decrease by 1 as you move from left to right. But our main work is to package them. How do you package them? Let me write some simple steps for us to follow. Step number 1, multiply. Step number 1, multiply the coefficient of x squared. The coefficient of x squared by the constant number. Coefficient of x squared by a constant number. So let's do that. So it means that coefficient of x squared means the number that is in front of x squared. So it is 1. We don't normally write it when it's 1. So it's 1. So the instruction says pick it 1, multiply it by the constant. 3 is the constant. So we multiply it by 1, and then we get 3. That is step 1. So step 1 says that pick the coefficient of x squared, multiply it by the constant, you get a certain number. And we have 3 here. Let's move to the second step. Now, second step says that find 2 numbers. Find two numbers from your results in step 1. Find two numbers from your results in step 1. And what did we do at step 1? Step 1, we multiplied the coefficient of x squared by the constant. Step 2 says that find two numbers from your results in step 1. Why? In such a way that, I continue, in such a way that when you multiply them, you get the results. But when you multiply them, okay, so let me complete the writing. When you multiply them, you get the results again. That's the first condition. Then there's a second condition. That's what I'm saying, but when you add them, you get the coefficient of the middle term. This is really a long step. So take note of this condition. It says that find two numbers from your resource. What is your resource? Your resource is 3. Find two numbers from your results in step 1 in such a way that when you multiply them, you get your results again. You get your results again. But when you add them, you get the coefficient of the middle term. In other words, when I take this one, I should look for two numbers for 3, in which when I multiply, I'll get 3. But when I add the two numbers, I'll get the number which is in front of the x in the middle term. That is what I wrote, the coefficient of the middle term, 4. That is what the step is saying. So what do? I pick the number 3. 3 can be multiplied by 1 and 3. When you multiply 1 and 3, you get 3. Again, when you have -1 and then multiplied by -3, that will also give you 3 in the middle. So it means that we have two options now. The two options that can give us 3 is either we multiply -1 by -3 or we multiply 1 by 3. But the second condition here says that those same two numbers, when you add them, you should get the coefficient of the middle term. And the middle term we have here is 4. And the 4 is a plus, so +4. Then you ask yourself, which of these two will give you +4? -1 and -3 cannot give you +4, so we can't use this one. But +1 and +3, when you add them, together, you get 4. So it means that the two numbers we are looking for in step 2, in our case, it will be 3 and then 1. These are the two numbers we are looking for in step 2. Then we move to step 3. Let me give you the step 3 instruction. Then we can do some work. So the step 3 instruction says that rewrite the original equation. Rewrite the original equation with the numbers in step 2. With the numbers in step 2. So let's do that. Now, the original equation that we were trying to work at, you saw it, is this one. This is the original equation. X squared plus 4x plus 3. So this x squared plus 4x plus 3. But the instruction here is that we should rewrite this original equation with the numbers in step 2. With the numbers in step 2. So let's go back to step 2. Step 2, what numbers did we get? We had 3 and 1 from the multiplication we did here. We had 3 and 1 for the middle term. For the middle term, 3 and 1. So what it means is that instead of writing x squared plus 4x plus 3, we are going to split this one with the middle term. So now our equation becomes x squared plus, instead of 3x, instead of 4x, we know that the numbers we had for 4 was 3 and 1. So we are going to split it into 3 and 1. So this is how we write them. So we have x squared plus 3x plus 1x. 3x plus 1x plus 3. So this is the arrangement we have done now. Instead of 4x, we have splitted it into 3x plus 4x. So it has become 4 now. We can now package these numbers now. And in packaging, you take them 2 by 2. You have this and that, and then you have this and this. Here, you have x here, you have x here. When you factorize x out, you'll be left with x plus 3 plus this one, x plus 3. No work there to be done. When you get to this point, you'll see that x plus 3 that you have here, you have the same thing here. And so because you have the same thing, you just pick one of them, x plus 3. That's the first package. And then the second package, you combine the numbers outside. So you have this x outside. You have 1 also outside here. We don't normally write the 1, but there's a 1 outside here. So you combine the x and the 1 here. That gives you x plus 1 as the second package. And at the end of the day, you have now factorized the expression. That this original expression we saw as x squared plus 4x plus 3 is the same package as x plus 3 into x plus 1. If you expand this one, we should get this one back. Let's try expanding it and you see x multiplied by x, you have x squared, plus x multiplied by 1, you have x, plus 3 multiplied by x, you have 3x, plus 3 multiplied by 1, you have 3. So when you wrap up here, you have x squared plus x plus 3x will give you 4x plus 3. So you come back to the original equation. And that is what we have done with the 3 steps we have learned today. Step number 1, multiply the coefficient of x squared by the constant. Then after that, look at the results, get 2 numbers in which when you multiply, you get the results. But when you add them, you get the coefficient of the middle term, like we did here. And then finally, go and rewrite the original equation with the results in step 2. What results did you get in step 2? You had 3, and then you had 1. And that was what we did here. And then we were able to separate them. Let's pick more examples to enhance our understanding. I'm sure by the time I finish with a couple of examples, the picture will be clearer to you. We will want to try our hands on the second question. And then if you have any question, you can ask before I proceed to the next thing I want to do. So you can pick your book. If you have your exercise book and your pen, let's try and work out the second one together. And then keep writing your questions. Once I open the floor, you can ask your questions. So this is the second I'm trying to do. That is number 2, or item 2. That is x squared plus 8x plus 15. Let's see how we can factorize or package this one. X squared plus 8x plus 15. We walk through the steps again. Step number 1 says that pick the coefficient of x squared. That is 1. Multiply it by the constant number, which is 15. 1 multiplied by 15, I will have 15 as my result. And this is step 1. Step 1, all that you do there is pick the number in front of x squared, which we call the coefficient of x squared, and then multiply it by the last number you are seeing here without x. The number without x, that's the last number. Now step 2. Step 2 says that we should do 2, or we should perform 2 activities there. He said we should look for 2 numbers. We should look for 2 numbers in which when you multiply the 2 numbers, you should get your 15 back. But when you add the 2 numbers, same 2 numbers, when you add them, the result should be equal to the number that is in front of x, the middle coefficient, 8. So the principle is get 2 numbers, multiply them and get your 15 back. But when you add same 2 numbers, you should get the coefficient of the middle term. So let's think aloud. 15 is the same as 3 multiplied by 5. No doubt about that. 15 also is the same as negative 3 multiplied by negative 5. 15 can also be 15 itself multiplied by 1 will still give you 15. Or negative 15 multiplied by negative 1 will also give you 15. So it means that we have a lot of options here. We have 4 options here. Either we can use this one, or we can use this, or we can use this third one, or we can use this fourth one to get a 15. But the question is, which of them will give us 8? We are looking for 8. Which of them will give us 8 when we add them? That is where you take a second look at the options now. If I add 15 to 1, I'll get 16. So this is not going to help us. If I add negative 3 to negative 5, we'll get negative 8. This option will also not work. If I add negative 15 to negative 1, I'll get negative 16. This option will also not work. But when I add 3 to 8, I will get the 8 I'm looking for, which presupposes that the two numbers we should use for this 15 should be 3 and 5. Then 3 multiplied by 5 will get us our 15. And again, 3 plus 5 will give us the middle term, 8 we are looking for. And that is the end of step 2. Now, step 3 said that we should rewrite the original equation using the results in step 2. So we are going to rewrite the original equation. And the original equation is, as you see here, x squared plus 8x plus 15. And we need to rewrite this one. In rewriting this one, we write the x squared like this, plus, instead of the 8x, we are going to split it with the two numbers we have here. The first one is 3, the second one is 5. So 8x is the same as 3x plus 5x. Then we bring your 15 plus 15 this way. And then you can see the change now. The number arrangement we used to be 3 terms, 1, 2, 3, has now changed to 4 terms, 1, 2, 3, 4. So if it is 4 now, it means we can group them or package them 2 by 2. So you bring your brackets to cover the first 2. You take your brackets to cover the second 2. Then you work individually on the 2 brackets or factors. I see x here, I see x here. I'll factorize x out and then maintain my brackets. After taking x out from here, it used to be squared here. Once I've taken 1 out, I'll be left with only x in the inner circle. You bring your positive sign. This 3x, the x has short out, so you are left with 3, only 3 here. You write your 3, and then you close your bracket. Then you turn your attention to the second bracket. You bring your plus. Let's look at the second bracket and see some common terms we can bring out. I see 5 here. I see 15 here. Since 15 is a multiple of 5, it means I can factorize 5 out. And if I do so, I'll be left with x here. You bring your positive sign. And once 5 has been taken out, you'll be left with 3 at this side. So at this point, after taking the factors out, then you check, are the inner ones the same? They are the same. I see x plus 3 here. I see x plus 3 here. As a result, you only pick one of them as the first package. And then the second package, you combine the numbers outside. I see x here. I see plus 5 here. And then you put them also together as x plus 5. And this becomes the final answer or packaging for item number 2. Any questions so far before I proceed to do the last example? If you have any question, you can put up your hand. Let's address it before I do the last example. Any question? All right, so I presume you are following the steps that we are all working through. Let's pick a third example to verify the processes we are using to get our answers. So let me tidy this place up. And then we pick the third example, which is x squared plus 9x plus 20. X squared plus 9x plus 20. And we apply same 3 steps to it to package the number into 2 factors, factor 1 and factor 2. So let's look at the third one now. This is the third one. X squared plus 9x plus 20. We kick off with step 1. Step 1 says that look for the coefficient of x squared and then multiply it by the constant term. So we have 1 here. I put my 1. We have 20 here. I put the 20. Step 1 says I should multiply these 2 numbers. 1 by 20. The result is 20. End of step 1. This is all you do in step 1. Pick the coefficient of x squared, multiply by the constant. You have 20. Then we move to step 2. Step 2 says this 20 that you have as a result, split the 20 into 2 by first of all looking for 2 numbers in which when we multiply the 2 numbers, we'll get our 20 back. And then at the same time, if we make an attempt of adding the 2 numbers, the result should be equal to the coefficient of the middle term, which is 9. We should be able to get 9 when we add the 2 numbers. So you vary your options and look for the numbers. And these are the options you can have. 20, to get 20 is the same as multiplying 20 by 1. That will give you 20. Or you can multiply negative 20 by negative 1. That will also give you 20. Or this 20 is the same as 5 multiplied by 4. That will also give you 20. This same 20, you can have negative 5 multiplied by negative 4. That will also give you 20. This same 20, you can have 10 multiplied by 2, and you are good to go. And then another option is negative 10 multiplied by negative 2 will also give you 20. So it means we have 6 options to choose from. All of them will give us the result of 20. But our main concern is that when you add those two numbers that you are going to pick, do they have the tendency to give you the number we are looking for in the middle of the expression, which is the 9? Is it possible all of them will give you 9? That may not be possible. So that's what you are going to use to eliminate the ones you need to eliminate. When you add 20 to 1, that becomes 21. 21 is not the same as 9. So we can't use this option. When you multiply negative 20 by negative 1, it will also not give you 9. So we can't use this option. If you add 10 to 2, that will give you 12. This option will also not work. If you add negative 10 to negative 2, that will give you negative 12. So this option is also not going to work. If you add negative 5 to negative 4, you will get negative 9. But what we are looking for is positive 9, not negative. So this option will also not work. So the only option that will work is 5 and 4, because when you add 5 to 4, you have 9. Immediately you see that you just split them. So you put your 4 and then you put your 5. So that 4 multiplied by 5 will give you this 20 you are seeing here. And then 4 added to 5 will also give you the option of 9 we are looking for. So we have now settled on the two numbers. And that brings us to the end of step 2. So quickly, we now move to step 3 with the results of step 2. We move to step 3. And this is what step 3 is saying. Write or rewrite the expression x squared plus, instead of the 9x, split it into these two. So we have 4x plus 5x plus the last number, 20. The arrangement has changed from 3 to 4. So you can now pair them up. You close them up 2 by 2. So this and that. And then look for the common factors. I see x here, I see x here. X is pulled out. After pulling x out here, you have x remaining. Plus, same thing here. After pulling x out, you have 4. Plus, then I have 5 and 20. And 5 and 20, 5 is common to both of them. So 5 is pulled out. You'll be left with x here. Plus, here you'll be left with 4. So we have two brackets having same contents. X plus 4, x plus 4. Immediately, you pull one of them out because it's the same thing. So we just need one out. And then secondly, when you finish, you combine the numbers outside, x and 5. So you have x plus 5. And that ends the packaging. It means that you've been able to package this long expression into two factors, factor 1 and then factor 2. So that has really ended this part for us, which is factorizing expressions. And I hope you try your hands on the rest in your own free time. And all the answers are here. So once you try them, you come and check with your answers. So all the ones we did, we are having them correct. We did this one, we had x plus 1 into x plus 3. We had this one also correct. And then the last one we did, we had this one also correct. So try 4, 5, 6 in your own spare time. Let's move on now to another technique we want to learn today. It's called, yes, Abraham.
All right, sir. Good
Yes,
morning.
morning.
Yes, please, thank you for your time and everything. So, when you are done solving, let's say, let's go to question number 2. Let's say when you are done solving and you have x into bracket x plus 3 plus 5, then x into bracket x plus 3. So are you going to bring the bracket, the one in the bracket first before you put the x plus 5 into the bracket?
Yes, so
Or
normally,
any of them can come first?
yes, any of them can come first, but in order to maintain consistency,
Yeah.
we always do what we know before we do what we don't know, isn't it?
Yes.
So the example you gave me, that at a point we had this one x into x plus 3 plus 5 into x plus 3.
Yes.
Very good. So this is my principle.
Okay.
This is what we know. We are seeing x plus 3 here.
Yeah.
We are seeing x plus 3 here.
Yeah.
And so like terms together, isn't it?
Yes, please.
So what it means is that this can shift here,
Okay.
or this can shift here.
Okay.
It's the same thing. So you pick that one out first. That is what we know.
Okay.
Good. And what we don't know are the ones outside. This
Okay.
x and this 5.
Okay.
Then you can combine them.
Okay.
But if you become a master of it, like I'm seeing, you can also write the one you don't know first before
Okay.
you write the one you know. In that
Okay.
case, you write the one outside first, which is
Okay.
x plus 5,
Okay.
and
That
then the
means
one.
at the end of the day, they will all, when you put them together, they will all give you back the
The same
expression.
result.
Okay. Okay.
They'll give you the same results. They'll
Okay.
give you the same results. So you can write any of them first. Either the
Yeah.
one you know first before the one you don't know.
Yeah.
And then when you multiply, you get the same thing
Mm.
at the end of the day.
So please, we want you also to try. We want to try the ones with a negative. I think the first number 1, number 2, number 3, they are all positive, positive.
I
So
agree.
we want to try the negative. I was
Yeah,
doing the number 4, and then I got
I
into bracket x minus 4. Then
no problem at all. That was a good observation. So I'll comply. Let's
okay,
do let's do one with negative.
yeah,
And those of you who are not seeing what Abraham is saying, he's saying that all the middle terms we have looked at so far, they are all having positive signs.
yeah,
But if you look at from 4 to 7, you have 4 negative, 5 negative, 7 negative. So let's pick one of the negatives and work it out. And probably I would prefer number 5 because of the 30 I'm seeing here. So let's try and work out this one and see the result. X squared minus 7x minus 30. So we go through step 1. Step 1 says that pick the coefficient of x squared. And I've told you that when you are not seeing any number here, it is 1. We don't normally write it. It's supposed to be like this, 1x. But it's looking funny. When you write 2x, that is okay. 3x, okay. 100x, that is okay. But the moment you write 1x, it looks funny. So we don't normally write the 1 if it's 1. So there's a 1 here. So you put this 1 and then you multiply it by the constant. If you are picking any number, pick the number with the sign in front of it. So you can't come and pick this 30 and leave this minus sign. Every number is accompanied by its sign. So if I write 2 plus 3, and then 5 minus 3, what I'm trying to tell you is that this positive sign here does not affect these two. It only affects the 3. So the 3 carries the sign. This negative sign you are seeing here, it does not affect the 5. It is only affecting the 3. So every number that has a sign in front of it carries, that's the word, carries the sign along wherever the number moves to. So that is the same thing I'm seeing here. I'm seeing a sign in front of the 30, and it's a negative sign. So I can't pick only the 30 and leave the negative. I have to pick all of them as negative 30. When I multiply 1 by negative 30, I'll have negative 30 as my result for step 1. So step 1 is telling me that when I do the multiplication of the coefficient of x squared and the constant, I have negative 30. Then I move to step 2. Step 2 says that I should find 2 numbers in such a way that when I attempt multiplying the 2 numbers again, I should get my negative 30 back. But when I make a second attempt, this time not multiplying, but adding same 2 numbers, the result I get should be equal to the middle term coefficient, which this time is negative 7. So then I start my search. I pick my negative 30. I ask myself, what 2 numbers can give me negative 30? The first thing that can come into my mind is that when I multiply negative 10 by positive 3, it will give me negative 30. My second attempt is, I also know that when I multiply 10 by negative 3, it will give me negative 30. My third attempt is that when I multiply 6 by negative 5, I'll get negative 30. Again, when I multiply negative 6 by 5, I'll get negative 30. Again, when I multiply 15 by negative 2, it will give me negative 30. Another option is multiplying negative 15 by 2. That will give me negative 30. So at least if I don't know anything at all, I know that these 1, 2, 3, 4, 5, 6 options, all of them, when I multiply them, I'll have negative 30. In terms of multiplication, we don't have a problem here. But the problem we have is, which of them can we add? Which of them can we add to get us our negative 7 we are looking for? And that is the second search you do. If I add negative 15 to 2, it will not give me negative 7. So it means that this option cannot work for me. If I add 15 to negative 2, that will be 13. That is not negative 7. So this option will also not work. If I add negative 6 to 5, that will give me negative 1. But I'm looking for negative 7. This option will also not work. Same with this one, 6 plus negative 5 cannot give me negative 7. Then I look here, finally, 10 plus negative 3 will give me positive 7. But I'm looking for negative 7. Then I try the last one, negative 10 plus 3. That is the one that is going to give me the negative 7 I'm looking for. So in other words, the two numbers I can use are negative 10 and then 3. So quickly I rush and put them here. In any order, you can bring the 3 first before the negative 10, or you can bring the negative 10 first before the 3. Any of them can be placed anywhere and you have the same results. So once I have the numbers now, it means that I have completed step 2. So I go to step 3 to do the rewrite. I'm going to rewrite the original equation one more time. So I have x squared instead of negative 7x. I'm going to use these two numbers. So plus positive 3x minus negative 10x minus 30. So my 3 term numbers have expanded to 4. I can then group them 2 by 2 and then look for common things out. I see x here, I see x here. So I pull the x out, and then this x squared, I'll be left with x. You bring your positive sign. This 3x2, you have pulled x out, so you are left with 3. You close your bracket. And then you have a negative sign here. And this negative sign you have here, if you put the negative sign here, like this, okay, we are pulling 10 out. I see 10, I see 30. So I'm pulling the negative sign out. So when you pull negative 10 out, here you'll be left with x. Now watch the side. We have pulled negative 10 out. So you can't put this negative here. It has to be positive. So that when you are going back with the expansion, you have negative 10 multiplied by x. That will give you negative 10x. And then negative 10 multiplied by positive 3 will give you negative 30. And so we are now have our common factors now, x plus 3, x plus 3. You pull the x plus 3 out. And then you combine the ones outside. You have x and negative 10. X and negative 10. And this brings you to the final results of question number 5.
Hello, sir.
Yes.
Please, can you go back? So where the x squared plus 3x is minus 10, mine, I did, I got x squared minus 10 into bracket plus into bracket 3 minus 30. Bracket.
No, you didn't do it well. This if you did it this way,
Yeah.
you wouldn't get what you had. You just follow. We are just following principle. We are just following principle. When the principle, I don't want the class to forget about this. When you get to this point,
yeah,
don't do any other thing by just using them. So look at this 3. That's what I fixed here.
Okay.
Look at this negative 10. That's what I fixed here.
Okay.
The x you are seeing at the back is because there's x at the back here.
Yeah.
That's why you are seeing those x. So immediately you get this, then you can then join them 2 by 2 like this. That is all. And then you factor the common things out. Very good. So that was a good question. Let's now move to the next technique. we want to learn today. Now, our second technique for the day is a very interesting technique. Now, remember my preamble. My preamble was that we are learning how to package. We are learning how to package. In this case, we are packaging numbers. And anytime you package numbers, you can only package the numbers into a terminology used called factors. You package numbers into factors. And once you package numbers into factors, it becomes more neater. It becomes more neater. It doesn't become clumsy, but you are able to make it simple for everybody to understand. Okay, so that is all we are doing. And we did the first technique this morning, which is called factorization. What we did is called factorization by quadratic. Okay. Now, our second technique now is called the difference of two squares. Very interesting. The difference of two squares. You don't do too much thinking when it comes to the difference of two squares. And that's the next thing we want to learn. Now, this is what the difference of two squares is saying. That anytime you come across two squares, anytime you come across two squares, I have x squared here, I have y squared here. Anytime you come across two squares and there is a negative sign in between the two squares, it is called the difference of two squares. It is called the difference of two squares. Now, how do we manipulate numbers that are in the difference of two squares? Simple. You don't work out anything. What this means is that write x 2 times and then write y also 2 times. How can you write x 2 times and y 2 times? This is how you proceed. If you have x squared minus y squared, like this, package them in 2 brackets. So first bracket, second bracket, write x 2 times or twice. So you write x 1, you write x 2. You are done with x. And then write y also 2 times. So look at the position of y. Y is at the second position. X is at the first position. So you put y at the second position like this, y. And then you put y at the second position again, y. Because you are supposed to write y also 2 times. Then the next thing is, y has a negative sign. When it is crossing the equal sign, it changes to positive. And then when this y is going back again to where it came from, it becomes negative. Then you put the negative here. This is the answer. You are done. So you write x 2 times, you write y 2 times, then you look at the movement of y. When y is moving across to the right, it carries a positive sign. When y is moving back to the negative side, it carries a negative sign. So let me give you an example, which we can confirm with your calculator if you have it, before I do the other expression. If I give you 6 squared minus 4 squared. Let's do it with our calculator. 6 squared, let's even behave we are in class 1 or primary 1. Let's try and work it like we are now learning how to do multiplication. 6 squared is the same as 6 multiplied by 6 minus 4 squared is the same as 4 multiplied by 4. 6 multiplied by 6 is 36 minus 4 multiplied by 4 is 16. When you take 16 from 36, your final answer is 20. This is a long root. Now, this is what we are learning today. Difference of 2 squares says that when you have 6 squared minus 4 squared, all you do is that put them into 2 packages. Just open 2 brackets. The first number 6, write it 2 times. So you write 6 here, you write 6 here. The second number 4, also repeat it twice. You write 4 here, you write 4 here. Last consideration, if this 4, which has a negative sign, is crossing over the equal sign, once it's negative here, when it crosses, it carries a positive sign. If this 4 wants to go back to where it came from and tries crossing again to the left side, it will carry a negative sign. So then we have 6 plus 4, 6 minus 4. 6 plus 4 is 10. 6 minus 4 is 2. 10 multiplied by 2, 20. And that's the same 20 we use the long roots to find here. So it's just a technique that repeats first number, repeat second number, change direction, move to positive, move to negative, and then the result is there. So when you are given algebraic expressions which look complex like this, and they want you to find the result of m squared minus 16, how do you go about it? M squared minus 16. The moment you see something like this, you try, dig into your memory and remember that, is there a way you can change this 16 to square? Because once you're able to change this 16 into square, then you can use the method we are learning called the difference of 2 squares. And I hope you remember that 16 is the same as 4 squared. So we can rewrite this one as m squared minus 16 is the same as 4 squared. So now we have the square now, which in principle says that open 2 brackets, write m 2 times. So you have your m here, you have your m here. 4 is at the second position. Write 4 also 2 times. And then when this 4, which is carrying a negative, is moving across, it will arrive with a positive. And then if it's going back, it will go with a negative. And this becomes your final answer. That is why you are seeing m plus 4, m minus 4 for the solution of this one. Let's pick more numerical example to enhance your understanding. But sometimes you can be given some crazy numbers to work on. So let's start looking at some uncomfortable expressions But once we are going to use the principle to work them out, I'm sure you understand what we are doing. Let's look at these 5 and why these answers were recorded. So I'll pick each one of them and then work it with you. Let's pick the first one. Now, the first one, we are asked to factorize t squared minus 81. Once I see only 2 terms like this, the square of a variable or a letter minus another number, the first thing that comes into my mind is, can I also write 81 in terms of a certain number squared? Yes. 81 is 9 squared. So then I rewrite this one as t squared minus 9 squared. The moment I have the structure, then life becomes easier now. We use the difference of 2 squares, where it says that just open 2 brackets first. So this is my first bracket, and this is my second bracket. And then the theory says that look at t, the first variable, repeat it or write it 2 times. I have my t here. I have my t here. Look at the second position number, 9. Repeat it 2 times. I have 9 here. I have 9 here. The 9 is carrying a negative sign. When it crosses, it will carry a positive sign. So I have t plus 9. When the 9 is going back, it will carry a negative sign. I have t minus 9. And this becomes my result. This is the answer. That if I have t squared minus 81, where I don't want to see the squared because it's making the expression complex, I can write it as 2 factors. That is t plus 9 and then t minus 9. So that is the first example. Let's use that idea to then do the others. The second one is r squared. So you have r squared minus s squared. Fortunately, all of them are squared now. Open your 2 brackets, bracket number 1, bracket number 2. Write r 2 times, so r, r. Write s 2 times, s, s. S is negative here, it will be positive here. S is positive here, it will be negative here. Done. This is your answer for the second one, and that's what you are seeing here. Let's now go more complex. Now this time for number 3, you have x squared minus 16 over 25. X squared minus 16 over 25. So you try and brainstorm that how can you be able to write this number as a square of a certain number? So you keep thinking that 16 is the same as 4 squared. 25 is the same as 5 squared. So simply put, you can rewrite this one as x squared minus, instead of 16, you write 4 squared divided by 5 squared. So one thing about algebra is that when you have 2 numbers in a fraction, the numerator and the denominator, and the numerator is squared, and the denominator is also squared, that means you can package them in one bracket. In other words, this can be rewritten as x squared minus, because this and this have a squared, we can bring a bracket, write the 4 and the 5 in, and then we put the square outside. So that when you go back, it will still be 4 squared, which is 16, and then 5 squared, which is 25. So once you have your x squared minus 4 over 5 all squared, you open your two brackets. So bracket number 1 and then bracket number 2. Repeat your x 2 times. So you have x. Repeat 4 over 5 also 2 times. 4 over 5, 4 over 5. 4 over 5 has minus here. When it crosses, it becomes plus. When 4 over 5 wants to go back, it will go back with minus. And this becomes your final answer. X into 4 over 5, one factor, and then the second factor, x minus 4 over 5. And that's the meaning of the answer you are seeing here as the third one. So let's look at the fourth one too. So the fourth one also follows the same principle. We have 49x squared. I'm just showing you the different forms. You can see them, so you always know the technique to use. The fourth one, I'm seeing 49x squared. So 49x squared minus 25. Now for this one, the dynamics has changed a bit. The 49 that is attached to the x squared, we have to do something about it. It cannot hang around that way. So we also think of what number can you square to get 49, and that is 7. So this can be rewritten as 7 squared x squared minus 25 is the same as 5 squared. All we are seeking to do is to make everything square. So we can use our formula. Also, in algebraic expressions, when you have two different items having square, you can also put them in a bracket and bring the square out. So you put 7 and x in the bracket, and then you bring their square out. Then when you are going back, it will be x squared and then 7 squared minus the 5 squared we have. Once we have settled on our square, it means we open our two brackets, bracket number 1, bracket number 2. The first term, 7x, write it 2 times. So I have my 7x here, and then I repeat the 7x here. Then 5, 2 times. I write my 5 here. I write the 5 over there as well. Then the signs, when negative 5 is crossing, it becomes positive 5. When positive 5 is going back, it becomes negative 5. And this becomes the final result. That's what they are seeing here. 7x plus 5, 7x minus 5. Let's end up with the last one. 64a squared minus 81b squared. Let's try and settle our understanding with this last one, and then I can open the floor for your questions. So let's proceed now. 64 squared, you write your 64a squared minus 81b squared. The technique is that any number that is attached to anything squared, force and break down that number also to look like a square before you can proceed. If you don't break all numbers to look like squares, you cannot go ahead and use the technique. 64 is the same as 8 squared. So we change it. We bring our a squared minus 81 is the same as 9 squared. Then we bring our b squared. We have also agreed that anytime you have two numbers or alphabets having square, put all of them together and bring their square outside. So this is the same as 8a, and then their square sits outside. Minus, we do same here, 9b, and their square sits outside. So we end up getting 8a all squared minus 9b all squared. Since we now have one general square before the sign, one general square after the sign, we open our two brackets. Put our first number here, repeated, 8a, and repeat it again, 8a. Pick the second one, 9b, 9b, 9b. 9b has negative. When it crosses, it becomes positive. When it's going back, it becomes negative. And this becomes our final answer. And that is what you are seeing here. So, ladies and gentlemen, this is what is known in introduction of maths as difference of two squares technique. Difference of two squares technique. Any question? Any questions so far on our second technique for the day? Any questions so far for the second technique? Right. So I'll presume again that you are fine with the second technique. And then that pushes us to do the last thing for the day. So let's move on and do our last. Yes, Stephen. Yes, unmute yourself and ask your question.
Sir, please, good morning.
Morning.
And good morning, class as well. Sir, please, will there be is it possible for a question to start with negative 49x squared?
Negative 49x squared. Yes.
That's number 4.
Yes, it can. So in that case, if they give you negative 49x squared, then the next one will be positive 25. So they expect you to rearrange it, that the negative will always have to be in the middle. So then when you are rearranging, you write the 25 first, then bring the negative 49. Then you can proceed with what we did today. So sometimes they can bring the negative out first before the positive. It's possible. Are you okay with that?
Okay, sir. Okay, sir.
Right. Any other question?
Thank you.
That was a good question. Any other question? All right. So let's pick our last topic for the day. And with that, we can then end the class for today. We want to look at something called rational numbers. You know them already, but let me just reiterate what you know. Rational numbers are any form of ratio that is written as A divided by B, where A is representing the numerator and B is representing the denominator. But the conditions are that both A and B must first of all be integers. And I hope you remember your integers. Integers are positive and negative whole numbers. When we're doing the number system, integers are both positive and negative whole numbers. So the condition is that, first of all, both numbers must be integers. And then second condition is that the denominator must never equal to 0. The denominator must not be 0. If the denominator becomes 0, then it doesn't qualify to be called as a rational number, because you can't divide any number by 0. Can you imagine me writing 3 divided by 0? If you like, do this on your calculator. 3 divided by 0. It will give you error. It doesn't exist. You can't divide 0 by any number. But if I write something like 1 over 3, this is rational, because 1 is an integer, 3 is an integer. Negative 2 over 3. This is also rational. Negative 2 is an integer. Positive 3 is also an integer. So any form of numbers you can write as up and down, top and bottom, we call them rational numbers. 5 over 6. 5 is integer, 6 is integer. Rational. Negative 3 divided by 5. Negative 3 is an integer, positive 5 is an integer. Negative 7 over 8. Integer. 14 divided by negative 3, rational, because 14 is an integer, negative 3 is an integer. So a rational number is any number that has the ratio of integers. It's any number that has the ratio of integers. Now, in algebraic expressions, remember the other time we were learning some stuff. We learned that algebraic expressions are alphanumeric. Alphanumeric. It means that they are combinations of numbers and alphabets. So the number part, we called it a number. The variable part, which is the alphabet, was the variable. And then if you remember, we were using operational signs like positive, negative, multiplication. Okay. And then we were writing stuffs like this: y squared minus 2y plus 6. This is alphanumeric, because I'm seeing alphabet and I'm seeing numbers. 2cd squared. This is also alphanumeric. I'm seeing number, I'm seeing this. So this is what we learned last week about algebraic expressions. But what I want you to know is that those ones were the normal algebraic expressions. What you learned last week were the normal algebraic expressions. Today we want to learn a different type from what we have done. And what we want to learn today is about rational algebraic expressions. It is totally different from what we learned last week, called the normal algebraic expressions. rational algebraic expressions. What are rational algebraic expressions? Remember, rationality, we said rational numbers are numbers that have two integers, an integer up and an integer down. But for the rational algebraic, you can have alphanumeric up and down. So look at this one, 4xy squared divided by 7y. This is a rational algebraic. 4 is an integer, 7 is an integer, x, y squared over y is an algebraic expression. So this is a rational algebraic expression. Again, you can have expressions such as this, x squared minus 3x minus 4, all divided by x squared minus 1. If you have something like this is a rational number. Rational number, because 2 and 3 are integers. But the moment you move to the alphanumeric, then it moves away from rational number to become rational algebraic expression. That is why you are seeing things like this. And this, a last example. If you see x divided by x squared minus 4, what does it mean? It means this is a rational algebraic expressions. Sometimes we cannot leave rational algebraic expressions like that. We have to put them into factors. Just as we have learned this morning, we need to be able to learn how to put rational algebraic expressions into factors. Into factors means that we need to be able to package them in brackets like this, curved brackets like this. We need to be able to package them. If we don't package them and they look something like this, they look a bit scary. When you see an expression like this, it looks a bit scary, but we should be able to do something, to do some packaging at the top, and then also to do some packaging at the down. In the course of the packaging, one package up may be able to cancel another package down. And by so doing, we can reduce the expression, which seemed to be very complex in the beginning. Okay. So let's look at some examples of reducing rational expressions. Now look at this rational expression. It looks so big. What can we do to reduce this to look smaller? We are going to employ everything we have learned today to reduce this to look smaller. And the moment it looks smaller, you come and have something like this. Just compare the two. This one looks more scarier than this one. I hope if you have to choose between this and this, you will choose this one, because this one looks very simple. And then this is looking complex. So let's see how we deal with this complexity by breaking it down to look simple. We are going to use all the techniques, like I said, we have learned today to do that. So let me pick that question. It says x squared minus 5x divided by x squared minus 25. Now, when I look up here, this is what I can do. I see x here. I see x here. So I can pull x out as a common factor. When I pull x out, I'll be left with x here. And then I'll be left with 5 here. So I'm done with the top. What about the bottom? X squared minus 25. if I watch x squared minus 25 critically, I'm seeing that I can do something about this 25 in terms of square. So you can remember that 25 is the same as 5 squared. So the moment you write it as 5 squared, then you have the difference of two squares now, meaning open two brackets, bracket 1, bracket 2. Write x 2 times. So you write x here, you write x here. Write 5 2 times. You write 5 here, put 5 here. First one is positive, second one is negative. So instead of x squared minus 25, then we come below here and we put x plus 5, and then x minus 5. Let's see whether there are some common things in the numerator and the denominator. So look at it, x minus 5, x minus 5. So this x minus 5 will cancel this x minus 5 because one is up and the other is down, so they can cancel themselves. And then finally, we'll be left with x alone on top, sitting on x plus 5 below. It means we've been able to reduce the expression from this complex form of x squared minus 5x divided by x squared minus 25 into a simple form of x divided by x plus 5. And that is what you can do with algebraic expressions, which is rational. Now let's look at a second example. The second example says you have x squared minus 25 divided by 25 minus x squared. Let's see how this one will work out for us to have our results. Let me write it up and then we work it together. X squared minus 25 divided by 25 minus x squared. So let's pick them one by one. Let's look at the numerator. Numerator, you have x squared minus 25. So by now, the experience we have it, we should be able to write this 25 in a certain number squared. And this will be 5. So 25 is the same as 5 squared. The moment you write our 5 squared, means we have difference of two squares. So we open our bracket, first bracket, second bracket. We fix x here, and then we repeat it at the side. We fix 5 here, and then we repeat it at this side. The first sign is positive, the second side is negative. So we rewrite this one as x plus 5 into x minus 5. Then we bring the division sign and then work at the second one. The second one is 25 minus x squared. So 25 minus x squared, we can think through that 25 is a certain number squared. It's the same 5 squared minus x squared. So we use the difference of two squares. We open our two brackets as usual, first bracket, second bracket. First number 5, we repeat it 2 times. Second number x, we repeat it here. First sign is positive, second sign is negative. And then we go up there and put it here. So we have 5 plus x into 5 minus x. So this is the situation we have now. And let's see whether we can do something. X plus 5, 5 plus x is the same thing. So we can rewrite this one to look like this. So we have x plus 5 into x minus 5 divided by 5 plus x is the same as x plus 5 into 5 minus x. So we do some cancellation. So this x plus 5 will cancel this x plus 5. Then the expression reduces to x minus 5 divided by 5 minus x. Now, when you look at these two, there's something similar, but they are not the same. I see x here. I see x here. I see negative 5 here. I see positive 5 here. What can I do? I want to rearrange this one to look like this one. So I'll still maintain my x minus 5 at the top and then rewrite this one. So this one, the x is carrying its sign, so I'll write it first, negative x. And then the 5 also carries its sign, positive 5, like this. I wish I could cancel them, but the sign here is not the same sign here. The sign here is not the same sign here. So the question is that, what can I do for this negative sign to live here? This is what I can do. I'll still repeat the x minus 5. And then this sign, I'll pull it out. When I pull this sign out like this, minus. When I pull it out like this x will be free to stand as x. But look at the 5. The 5, I cannot write positive 5 because when this sign is going inside again, I have to get positive 5. So once I've pulled negative sign out, then the 5 changes from positive to negative like this. So that when I'm going back, this minus will affect this x. And then this one will be minus, minus, then I'll get my positive sign out. So with this technique, I've been able to make them the same. So negative 5 will cancel itself 1. It will also cancel x negative 5, 1. So finally, I have 1 at the top and then have negative 1 down. When you divide 1 by negative 1, your final answer will be negative 1. And that's the answer you are seeing here. This is the reason why the answer is negative 1. Any question about this solution? Algebraic expression, rational algebraic expression. Any question about the reason why we had negative 1 as our answer, final answer? We were just using the techniques we have learned today, and the 2 techniques we have learned today, if I'm to recap, are as follows. When we started today, 1, we learned how to factorization. And then we learned how to use the difference of 2 squares. And then our final topic we have done today is called rational algebraic expressions. Rational algebraic expressions. And I'm sure when you see questions on this, it will not be too difficult for you to work with the techniques. So this is my last example I want to work today. I'm still waiting for your questions. Any question about this long solution that gave us -1 in the end? We're just using the concepts. So interestingly, see how it started. The thing started as a rational algebraic expression. So that's what we saw here. Rational algebraic expression. Then we moved into using the difference of two squares. The difference of two squares to break it down to x plus 5, x minus 5. And then when I was about to end, I used factorization. So we use factorization in this place. And so we have used all three concepts we have learned today. Yes, Stephen? Yes, Stephen, unmute yourself and ask your question.
All right, sir. Thank you once again. Sir, please, can there be a question whereby it will be x squared minus one whole number, maybe 3/4?
I'm coming. Let me write what you are saying. Say,
All
can there
right.
be a situation whereby what?
It will be x squared
Yes.
minus one whole number, 3/4.
Mm-hmm.
All over 25x.
Is it this one? You are talking about this one.
No, all over. All over.
I'm coming. X squared minus 1 whole number 3/4. And all
All
over
over. All over 25
mm-hmm.
minus 1/2x.
Are you creating your question?
No,
I want
say. Okay, say minus 1/2. Please delete the x.
mm-hmm.
Yes, please. Can there be a question in this form?
No, as for the question, it can be put in any form. Once they give you the form, just use the principle we have used today. That is all. The question can be put, it can be set anyhow, any arrangement. Anyhow, any arrangement. All you need to remember is that three things. How did we do the factorization today? How did we do the difference of two squares today? How did we do the rational algebraic expression today? Once you remember the procedures we used for item 1, 2, 3, any question at all that is given to you, like the one you are setting, you should be able to solve it. Are you with me?
Say, please, I'm with you.
Yes. So you just use everything we have been through today, or we have learned today. Yes, I'm with you. I'm listening.
Okay, sir. So please, say, I don't really know whether I can work out this one with us.
No. This one is not a good question. It's a bad question.
Oh,
That's what
okay.
I'm telling you. You are just setting a question for yourself.
Okay, sir.
It's a bad question. It's not. That's why I repeatedly I'm referring you here. Your question must conform to these three. First of
All
all,
right.
it must be a rational algebraic expression. Secondly, it must follow difference of two squares rule. Thirdly, we should be able to factorize it.
All right, sir.
That is where the question should be structured. But the example you gave, it is not conforming to this 3.
All right.
Right. Any other question? Because I'm done for the day. Any other question? All right. So
Yes, sir. Please, I want to ask, like, is every math question a question that have been solved before they bring it to us or something?
now repeat your question again. I want to understand it well.
Yeah, I'm trying to put a question well myself. Like, when it comes to math questions, are there questions that are already solved and they've gotten an answer to it before they set them?
You mean for exams or real life?
Yes, in general.
No, in general, some math questions are known, some too are unknown.
Okay.
So the ones that are known, they are put in books, textbooks.
Okay.
The ones that are unknown, that is where we do what we call a research to know it. So simply put, and direct answer to your question is that not all math problems that are set have been solved. That is what I can tell you, because some are unknown.
Okay, because the last time you mentioned that when you are given a question with possible answers, and then you solve the question and you realize the answers are not among the possible answers, then you write it over there as maybe D or E. And
But that one is not what your question is about. That one, you see, I asked you that is your question about real life, and you said in general, isn't it? Hello, Abraham.
Yes, please.
Yes, in general means you are talking about real life. But what I mean is that in this world, nobody is perfect. In fact,
Okay.
I haven't seen any human being who is perfect. We all make mistakes. So probably this is the question I want to bring in exam. I gave it to the person who typed my questions to type it so I can go and print. And maybe mistakenly, instead of the person typing this question, the person did it as x squared minus, instead of 25, the person typed 100 divided by 25 minus x squared. This is what the person typed instead of this. Meanwhile, me too, my answers have arranged for this. For the person to type is probably A is equal to this -1 we had. B is equal to 2. C is equal to 3. And D is equal to 4. So these are my answers for this question. And I know that when I'm marking, it is A that should be the correct answer. But the person didn't type this question. Mistakenly, the person typed what I've written here for you. And then you also worked it correctly using factorization, using difference of two squares, using rational algebraic expressions. And then finally, you had an answer of 5. And you came to check your answers, and your answers are not here. What I was saying the other time is that because I know that some of these things can occur, all my possible answers, I've added E. It's not A to D. I've added E. And the E, this is what I've written there. None of the above. None of the above, meaning the answer is not in. So what I was saying was that in case you work a question and your answer is not within the answers that has been given here, just go and choose E. none of the above, because your answer is not within the answers that have been given.
Okay.
And once you choose that, and then I check that really it is true, your answer is correct, then quickly I'll mark you correct.
Okay.
Any other question? Yes, Abraham, thank you. Any other question? All right, so if there is no question, we want to end the class today. We have done almost 2 hours. And I wish you a good weekend. Hopefully, we will continue next week.
Hello, sir.
Yes.
Please, I think we are grateful for your time and everything, your explanation and all. And then secondly, I think I gave you a proposal the last time. If you can spare us some of your time by taking us through some of the questions again, maybe.
Yeah. Don't worry. I think I told you that I will have to prepare you for exam before
Yes.
you do exam. So along the way, let's finish some topics and then we will do a general revision.
Okay.
Whereby we pick them topic by topic. So questions that you have issues with, then we can work them together.
Okay, please. All right. Thank you very much.
All right. So on that note, I wish you a good day. The class is officially ended.
Thank you. Have a blessed day too. All right, so I think we will be waiting for the next class. It starts in the next 15 minutes. Yeah, exactly at 9:15, we'll be back and then we'll start. Thank you. Don't worry, you all get it, okay? I know some of us are